So hello everyone, this is lecture 18 and this is gonna be very interesting, this lecture. Okay, in the last lecture we studied about the orthogonal transformation and I told you something about the unitary transformation, that it's the same as orthogonal transformation. And we know what is unitary matrix, where A dagger is equal to A inverse, then we call A as the unitary matrix. Okay, so what happens if you operate a unitary matrix on any vector and you get a new matrix? Okay, that is unitary transformation. So here also it preserves inner product of vectors a and b. So first you get this transformation of a as u, transformation of b as v, then inner product of ab will remain same as u dot v. Means it preserves the inner product. And how you will check this inner product will be a conjugate transpose b, and as it is u conjugate transpose v. That's how you can calculate inner product. It also preserves the length or norm of the vector, like u will remain length of u will remain same as a and length of v remains same as b, just like same as in the orthogonal one. And same as in orthogonal, a complex square matrix is unitary if, means if and only if, its column vectors a1 a2 a3 or its row vectors form an unitary system. Means if this is a matrix, then this a1 vector and a2 vector should follow these all rules. Means inner product of a1 dot a2 should be equal to 0 if I and j, means these are the conditions. ai dot aj equal to 0 if I is not equal to j, and it will be 1 when I equal to j. Okay, so each column vector and each row vector should be follow these rules. Only then we call this matrix A as unitary matrix. Okay, that's how you can check. Now we also can verify the conditions of preservation. Means if A is this and B is this, and we have this unitary matrix A, then operate this on A, we'll get this. Operate this on B, we'll get something, some matrix column vector. Then we will take the inner product of u and v, and a and b will remain same. Means u this and length of v and b will remain same, and length of u and a will remain same. Means that's the same as we did in the orthogonal matrix. So here are the, this will remain same. Okay, inner product and the length and norm. So it's easy. So what we will do today is this: similarity of matrices and basis of eigenvectors and diagonalization. These are very interesting topics. So what are they? So what is the meaning of similarity of matrices? An n into n matrix A cap is called similar to a n into n matrix A. Means there is a possibility a matrix A cap which will be called to similar to A if A cap equal to P inverse AP. Here P is some non-singular matrix. Okay, any non-singular matrix, then its inverse, and will multiply with this. Means this product will give you a matrix which is similar to A. So just remember this, we'll understand more. And this transformation of A is called the similarity transformation. Means A will turn into the A cap. This is called the similarity transformation. Now if A has some means the eigenvalues, if we talk about, then A cap will have the same eigenvalues as A after the transformation. Now if x is an eigenvector of A, if x is an eigenvector of A, then the P inverse x will give us the eigenvector of A cap corresponding to same eigenvalue. Okay, now we need to prove this statement. Let's say if x is the eigenvector of A, then we can write this equation as Ax equal to lambda x. Okay, now let's multiply with P inverse on both sides, and P inverse Ax will give us P inverse lambda x. Now P inverse let's say lambda will came out and P inverse will came in. Now here is nothing, but we can write it as P inverse. This will give us identity matrix, so we can write P inverse Ax as P inverse A P inverse x. This can be removed, this is just I, so we can write it like this. Okay, now what is P inverse AP? This is A cap. So A cap P inverse x. Now we write P inverse x as y. So you get this equation: A cap y equal to lambda y. Now this is the equation which can give us the eigenvectors, which is y. So means y is the eigenvector with the same eigenvalues as lambda, which was of a. Okay, so now we get that if eigenvectors of a is x, then what are the eigenvectors of this a cap? They will be p inverse x. P inverse x. Just remember these results, very important. Now there are some more properties of this similarity transformation. What will be the trace of a cap? That will be same as trace of a, and the determinant of a cap will remain same as determinant of a. And if lambda 1, lambda 2, lambda n are distinct, means these are the eigenvalues of a. If all are different, means non-degenerate, then eigenvectors corresponding to them will be called the linearly independent set, and these are called the basis of eigenvectors. Means all those eigenvectors are bases. Okay, basis of eigenvectors. Just remember these. We will use them. Now the next is diagonalization. Here we will use the similarity transformation. What is diagonalization? It's a transformation of a matrix into a matrix which is diagonalized. Means that will turn that matrix into a diagonal matrix. And what is diagonal matrix? Where all the diagonal elements are non-zero and all the non-diagonal elements are zero. So how can we do that? So if an n-to-n matrix A has basis of eigenvectors, that is x1, x2, x3 corresponding to lambda 1, lambda 2, lambda 3. Okay, so what will be the diagonal matrix? That will be equal to x inverse ax. This will give us a diagonal matrix, is diagonal with eigenvalues of a on main diagonal. Means this is what similarity transformation of a. And what is x here? What is x here? X is when you solve a and calculate its eigenvalues and eigenvectors, then those eigenvectors put in a matrix. Means you will get one column vector, two column vector, and third column vector of eigenvectors. Put all them in a matrix. Then that complete matrix is called this x. Okay, and means all the eigenvectors or basis of eigenvector put in a matrix. Then that matrix is called the x. And if you multiply with inverse and x with a, you will get a diagonal matrix. We will see with example, you will understand more clearly. Here x is a matrix with these eigenvector as a column vector. Okay, this is what I just told you. And when you get the diagonal matrix, it will be like all the eigenvalues of a will be on the diagonal and all other elements are zero. That kind of matrix you will get after doing this operation. Let's see an example, you can understand more. So if given matrix is this 5, 4, 1, 2, okay, so calculate its eigenvalue. It will give you a minus lambda I with the same operation, 6, 1. So what should be the diagonal matrix of this a? That should be 6 and 1. So D should be 6, 1, 0, 0. This should be the diagonal matrix. So let's see if this operation gives us the same matrix or not. Okay, so first one we need to find the corresponding eigenvectors to 6 and 1. So let's calculate. So you can calculate the eigenvectors, you know how to calculate. So you will get x1 as this 1 by root 17, 4, 1 after normalization, and x2 as 1 by root 2, 1 minus 1. You will get these two eigenvectors. Now you will put these eigenvectors in a matrix, single matrix. It's 4, 1 here, 1, 1, 1 minus 1 here. Okay, so you can put all complete normalized vector also, or just single this. You will get the same result. Okay, and I just take these non-normalized here. Now x is this. You can find the x inverse by 1 upon determinant of a and then adjoint of a. So you will get x and x inverse. Now what you need to do is x inverse ax. You have a, you have x inverse, you have x. Just operate it and you will get this matrix. So it's just same as I told you. I just told you by just seeing the eigenvalues that it should be this, and you'll get the same result. So that's how you can diagonalize a matrix. So what is the use of these matrices and all? We will study in the next topic, which will be the rotational matrix. Now just understand what is diagonalization, how we can achieve this. Okay, just understand this more. So there is one more example. A matrix is like this and we have the eigenvalues. then you know what will be the diagonal matrix. This 3 to 1 will be on diagonal. This should be the diagonal matrix. But you can prove this, that it will came out this, by finding the eigenvectors corresponding to this, this and this. So x1, x2, x3 are these. Put all of them in a single matrix, then find the inverse, then operate it on the A, x inverse A x, then that will give you D, and they will came out to be this. It will remain same. So hope you get this idea. Now let's solve some questions which can be asked related to these concepts. Now if given matrix is this and M is given like this, where this equal to x inverse mx, so we need to find x. So what will be x? So we know what is x. X is nothing but the first we need to find the eigenvalues, then find the eigenvectors, and those eigenvectors put in a matrix, that will be x. So it will take very long time. So what we see here, this is a diagonalized matrix because of this. So these are nothing but eigenvalues of this matrix. So we have already the eigenvalues. Now just we need to find the eigenvectors corresponding to these lambda 1, lambda 2. So we can find them just the way I told you how to calculate eigenvectors. Okay, so same way you will find, and you will get the eigenvectors as this and this. These are the eigenvectors. Now just put them in a single matrix, that will be your x. Okay, now there is one more kind of question can be asked. Eigenvalues of a 3 into 3 matrix are these. Eigenvalues are given. Now the corresponding eigenvectors are also given, and we need to find the matrix M. Now we need to find this matrix M. So you know that how can we find this? So a diagonal matrix will be given by x inverse mx. So you know that. Now we have D matrix already, but now if we need to find M, so how we can do that? So we'll operate x inverse on both sides. Here also x inverse. So this will give us I, this will give us I, and then it will turn out to be M equal to xd x inverse. Now what is D matrix? D matrix can be find directly. If eigenvalues are lambda 1, lambda 2, lambda 3, put them on the diagonal. This. Now you have eigenvectors, so you can find the x and x inverse also. Now just put in this operation and you will get the M. It will be this. So practice these questions, try to solve them completely, then you will have this intuition, solve the questions. Now let's see a new topic, or the last topic of this lecture, that is functional matrix. What is functional matrix? Means a particular matrix is a function of itself. Okay, means it's a function. That's how you can describe the functional matrix. So we get D as x inverse Ax, and we know that what is A. When you put x inverse here, then you will get A is equal to x dx inverse, just what we did here. So you need to remember these formulas. Now what will be the FA? Means the functional matrix of A will be equal to x inverse FD. Just remember this as it is. I will told you in the examples what is the meaning of this. You will understand more with these examples. But if A is diagonal, then you don't need to put this x inverse. FA will be equal to FD. So just remember these results. Now let me show you what is this all. Now if given matrix is this A, now it is diagonal matrix, so FA should be equal to FD. Okay, now if matrix is given and you need to find EA, so you will just put them in place of A, the 1 and 2. So EA will be E1, E2. And if you need to find A100, then just put them 1 to the power 100, 2 to the power 100. Means in place of A, these elements will come. Sin A, then sin 1, sin 2. Just directly you can put. Because it is diagonal matrix, then FA should be equal to FD. So that's the meaning of this thing. Just remember this as it is. Okay. Now if this matrix is not diagonal, then what? If the given matrix A is this is non-diagonal matrix because elements should be here. and but elements are here, so it's a non-diagonal matrix, and we need to find EA. Now FA is not equal to FD. Now what formula will work? FA should be equal to X FD X inverse. So first we need to find the X, then we need to operate it on the FD. Only then we can find the FA. So it will be a long procedure. Let's see. First you need to find the eigenvalues of this matrix. That will be 1 minus 1. And from here you can calculate the diagonal matrix directly because in the diagonal matrix these eigenvalues are nothing but just put on the diagonal elements. 1 minus 1. So this is D. Now what will be the X? Find the eigenvectors corresponding to 1 minus 1. X1 will be this, X2 will be this. Put them in the single matrix, then that will be X. Now you can find the X inverse, and see here it is orthogonal matrix, and so it just transpose of this will give you the inverse, so save some time. So X inverse will be this. Now we have D, we have X, we have X inverse. Now what will be FA? It will be X FD X inverse. So what is FD? FD for this EA, that will be EA is equal to X ED X inverse. Just remember this, because from this formula FA equal to X FD X inverse. If it is E to the power A nikalna, then E to the power A equal to X E to the power D X inverse. So now we have X, E to the power D will be, it will be E to the power 1, E to the power minus 1 here, and you have X, you have X inverse. To solve this, and you will get E to the power A as this. Okay, so if it is non-diagonal, then you have to calculate this all of things, and then you will have this answer. Now there is one more thing. If they ask you that find the determinant of this EA, then how can you find? You know from the property determinant of EA equal to E to the power trace A. And what is trace A? You can directly see 0 plus 0, 0. So it will give you 1. So determinant of this matrix is 1. So try to use these tricks and solve them fast. So you need to try this one more question based on this. If M is given this 2 1 1 2, we need to find cos pi m by 6. So this is a functional matrix, means we need to find this function. This is depend on this matrix. So it is FA, means FM. So what will be FM? So for that we need to find FM first. So for that FM equal to X FD X inverse. So first we need to find the eigenvalues of this. This will be 3 1. So we have the diagonal matrix, that will be, diagonal matrix will be this 3 1 0 0, and corresponding to these we have we can find the eigenvectors, and that's how we can find the X and X inverse. So we have these values. Now what will be the FD? So FD will be, put D here. So D will are 3 and 1. So cos pi 3 by 6 will came here, and cos pi pi by 6, that will be 1 multiplied, will be here. So this will be FD. Now you have FD, you have X inverse, you have X. You can find the FM just operating this way. Okay, so you have FD came out to be this, and you have all the values. Now you will get the FM just by solving this, means after operating this operation you will have the answer. Is X FD X inverse. This will give you answer of this cos pi m by 6. Okay, in the next lecture we will see one or two more examples, some different examples. Then there will be the last topic, that is rotational matrix. Then our matrix of this mathematical physics will be over. Thank you everyone.